Okay, so beginning with, or running into now chapter 5, lesson 5.1, we're going to take some time to briefly review our exponents. This is a topic that you've seen before, and so we're going to hit the highlights and just to recall what those exponents mean, what they are, and so on. So powers and exponents, which again sometimes called powers, but the mathematical term exponents. Exponents are used to represent repetitive multiplication, multiplying the same factors or the same number over and over again. When you go backing up to when you learned multiplication, multiplication was repetitive addition, where you would take a number like 4 times 3 is 3 fours multiplied or added together. Excuse me. In this case, we're talking about taking a number and multiplying it by itself over and over again. Now, so here I have 3 to the 5th power, and first thing we need to just review briefly are the parts of our exponential notation. Okay, we have 2 parts when I say exponential notation, we are talking about a number written as a power. Okay, so the first part in exponential notation is the base. And the base in this case is our 3, and that is the number that is being multiplied repeatedly. Okay, so that is the number that is being multiplied over and over again. 5 in this case is the exponent. And remember, this will tell us how many times the base is being multiplied by itself. So when we have 3 to this power, it means 3 times 3 times 3 times 3 times 3. 5 3's multiplied together. It does not mean 3 times 5. Okay, 3 times 5 is 15. 3 to the 5th power is much larger than 15. 3 times 3 is 9. 9 times 3 is 27. And you'll see we are already bigger than 15. So that's that first thing that we have to get out of our mind, the fact that we are not, it is not 3 times 5. It's the base number multiplied by, or using the exponent, it's this number multiplied by itself this many times. So we're going to, again, just quickly hitting what these things mean. 2 to the 6th power does not mean 2 times 6. This is not 12. It means 2 times 2 times 2 times 2 times 2 times 2, which we can then go to what is the answer to that later down the road. 3 to the 8th power means 3 times 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 3. You'll notice there are 8 of them. Okay, and this is where we have to understand that 3 to the 8th power and 8 to the 3rd power, different values or different ideas. Okay, 8 to the 3rd power is 8 times 8 times 8, and you will find, and we're not going to do it right now, but 3 to the 8th is a much different number than 8 to the 3rd if we were to multiply all these 3's out and then multiply these 3 8's out. Okay, so just throwing that out there, just to, again, quick review of what things mean. Okay, so now taking it to the next step, 4 times 4 times 4 times 4 times 4. We're going to first write as an exponent, and then we're going to write its value. Okay, so 4 times 4 times 4 times 4 times 4. Looks like there are 5 4's multiplied together. So that is 4 to the 5th power. And then if we multiply across 4 times 4 is 16. And you can actually, if you want to, 4 times 4 is 16, and then multiply by another 4, multiply by another 4. Or you can go 4 times 4 is 16. This 4 times 4 is 16. You can multiply those together, then multiply by this 4. However you want to do that multiplication, it will end up being 1024. Okay. 6 times 6 times 6 is 6 to the 3rd power. Not 6 times 3. 6 times 3 would be 18. 6 to the 3rd power is 216. 6 times 6 is 36. 36 times 6 is 216. Okay. 1 times 1 times 1 times 1 times 1 times 1 times 1 is 1 to the 1, 2, 3, 4, 5, 6, 7 ones. 1 to the 7th power. Now, a lot of people will try to tell me that the answer to 1 to the 7th power is 7. It is not. This is not 1 times 7. This is 1 times 1 times 1. That's 1. 7 times 7, well, that's 2 7's multiplied together. 7 squared. 7 times 7 is 49, not 14. 4 5s here, so 5 to the 4th power, and 5 times 5 times 5 times 5 is 3,125. And you'll notice we have 1, 2, 3, 4, 5, 6, 7, 7 2s. So 2 to the 7th power is not 14. It is 128. I just want to briefly touch on a few of our special phrases that we use when we deal with exponents. The idea of squared. Things to the 2nd power are squared. Okay, so 4 squared. And we get into that. That idea comes from finding the areas of shapes. Okay, because when we do areas of shapes, we very literally figure out how many square units fit into a shape. Cubed. Cubed is our 3rd power. Okay, so 8 cubed is 8 to the 3rd power. So when you see cubed, we're talking about things to the 3rd power. And when we do that, we are talking about volumes. And when we get later down the road, when we talk about volumes, you'll see where that application comes into play. Now, usually beyond squared and cubed, 2nd power and 3rd power, we just go to the power of. Okay, so 2 to the 6th power in this case, 2. 6 is our power. Okay, 8th power, 2 to the 8th would be 2 with an 8, and so on. We don't have those special names really once we get past 2 and 3. And then we're just going to go a little bit back and forth here now. Going to complete the empty spaces. We're going to fill them in. And in this particular case, this column here, we're going to fill in with our exponential form. So we want to write the number as an exponent. And in this column, we're going to go to expanded form. And then at the end, we'll put the actual value. So 4 to the 3rd, we know is 3 4s multiplied together. 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. Okay. And so these values here are all equal to one another. You have to realize that they are all the same value. They just are different forms of the same value. Okay. 1, 2, 3. There are 4 3s here, so my base number is 3. There are 4 of them, so 3 to the 4th power. And when I multiply these 4 3s together, you'll notice I get 81. And so understand 4 to the 3rd and 3 to the 4th, even though they're the same numbers, because of their positioning, that changes the actual outcome. 100. Now, you actually have some choices here in 100. When I did 100, and I went 10 times 10. Okay, and 10 times 10 is 10 to the 2nd power. The one other option that you have in this one that I didn't really think of when I put it together, although as I'm sitting here giving the lecture, so to speak, 100 is also 100 to the 1st power. So in this column here, we could have 100 to the 1st power, and then in this column, just 100, and that would also, so we have an alternate form for that. So, but anyway, 3 5s is 5 to the 3rd power. 5 times 5 is 25. 25 times 5 is 125. 2 to the 7th is obviously 7 2s multiplied together. I had to shrink them down a little bit to get them to fit in the space. 7 2s multiplied together is 128. And 11 times 11, well, that's 2 11s, so that is 11 to the 2nd power. 11 times 11 is 121. Again, that gets us through our quick review, so to speak, of exponents and exponential form and so on. Time for you to do some review of your own. Good luck. Come see me if you need help.